Hi, I'm Buddy Researchers, and we are back. This time, we will focus on the demonstration of using SPSS in understanding correlational analysis. So here's the case study. Now, I'll be using my own study here because I've used correlation, Pearson's R correlation when I did my grad school thesis. So, exploring molecular genetics, metacognitive awareness, self-efficacy, and metacognitive classroom environment. Now, in this case, yours truly conducted a study consisting of 86 grade 10 students of the Ateneo Junior High School, and he focused on the relationships of students' conceptual understanding of molecular genetics, their metacognitive awareness, perceived self-efficacy, and view of metacognitive classroom environment. All data were gathered using questionnaires, and he hypothesized that MASS, MCE have positive and statistically significant relationships with the CMG. So be able to test this hypothesis by using the ideal statistical analysis. Okay, this time I have opened my SPSS file, so you can also download the SPSS file so you can explore the necessary details, how to go about the correlation test in SPSS. So please do check the necessary details here. So you have participant, and take note that it's a nominal measure. And you also have the different tests as mentioned in the case study. So you have the genetics test, you also have the metacognitive awareness test, the science self-efficacy test, and the metacognitive classroom environment test. So we can set all up to 2 decimal place values, and all of them are scale measures. So looking at the data view, so you have specific data here already. So you have the genetics test, metacognitive awareness, science self-efficacy, and metacognitive environment. Now, I would say that Pearson's R correlation, you can consider, or you can conduct this test in a very simple manner, and it's not really complicated. So I think there are 3 clicks or 3 steps, then you can complete now your correlation steps. So first, we need to explore the normality of our data. So just to check if it's ideal for us to use Pearson's R. So like what we have done in the past. So what we do is to click descriptive statistics, and then you click explore. So you just place all data here except for participants on the dependent list. And you click, let's check again. So 95%. You have plots also. Click histogram and then normality plots. Then continue. Then you click OK. So let's wait for the generated result. So analyzing now the normality of our data. So maybe we can go directly to the test, since you can see here on the test of normality. So they're all greater than 0.05. So we can assume now that the data is normally distributed. So which means it's ideal that we use Pearson's R in analyzing the correlation, the relationship of all the variables here. So going back to our data view. So how do we apply now correlation? So you click analyze, then you click correlate, then you click bivariate, then I just return them here because I've tried to explore earlier, so they are all here. So what we will do is to place all these variables. Kulit, ibabalik ko na naman doon. So here, so variables, metacognitive awareness, science self-efficacy, and metacognitive classroom environment. We disregard participant because that's just a label. Then you click Pearson, since we have explored that it's normally distributed, so we can use Pearson's R. But if it's not normally distributed, then we have Spearman. Then two-tailed, then options. So you click also means and standard deviation so that you can add on details in your interpretation later. Then continue. Okay, then I'll click now this one. And this is the result for correlation. So you have here the descriptive statistics, you have the mean scores, and you have here correlational results. So you have, how do we interpret this table then? So let's focus on the interpretation. Now, as you can see here, you have the correlation table focusing on the different variables, genetics tests, then checking if there's a relationship with itself, and you can see it's 1. So when we did with our discussion earlier, positive 1 coefficient would signify that there's perfect correlation. So, but obviously it's the same value, so we expect that they have direct correlation there. And for metacognitive awareness and the genetics test, what I usually check here is the p-value, the sig value. So we have here, if it's less than 0.05, then we can assume that there is a significant relationship between the 2 variables. So metacognitive awareness compared to genetics test. So we can see that, so there's no significant, what do you call this one, relationship because it's greater than 0.05. Then for metacognitive awareness and science self-efficacy, so it's less than 0.05. So there is a significant relationship. And also with the metacognitive environment. So science self-efficacy as compared to genetics tests, you also have what do you call this one? Significant relationship, even in metacognitive awareness. So you have those things. And then metacognitive classroom environment. Well, if you can see, it's like a flipped version of the other side. So it's already a repetitive way for me to explain. So we can now consider that the following variables, they have a significant relationship. And you can also see on the result, the asterisk having this legend that if you only have one asterisk, so it's significant at 0.05 level. But if you have two asterisks, so it's significant at 0.01 level. So you can see here the necessary results. Now, how do we interpret? This is an example way of interpreting correlational results. Pearson's R correlation. Results of the Pearson's R correlation reveal that there was a significant positive relationship between genetics test scores and students' perceived self-efficacy in science. Then you can have the notation of R, the value, so 0.23, and then the p-value, it's less than 0.05. Also, a strong significant positive relationship was observed between science self-efficacy and metacognitive awareness. You have the R value 0.8 and the p-value less than 0.01, not 0.05, because you can see the asterisk already. While a moderate significant positive relationship existed between metacognitive classroom environment and students' metacognitive awareness, and the R value is 0.56 and it's less than 0.01 significance also. And between metacognitive classroom environment and science self-efficacy, and you have R 0.49 and then the p-value is less than 0.01. That's how you simply interpret Pearson's R correlation results. If there's a significant relationship, so if one increases, the other increases, if one decreases, and so on. Now, but there's a Gantt data presentation, and you can explore the chart builder feature of SPSS because we're trying to consider here the relationship between the two variables, the trend. Now, so you can use now the chart builder feature of SPSS and just lifting the same interpretation. So instead of a table, you can have chart and you can have the regression line here, there. So at least you can see between genetics tests and science self-efficacy, that's a distribution. And then you can see the closeness of the values on the regression line. And you can see here a very strong correlation between science self-efficacy and metacognitive awareness also. And even metacognitive awareness and the classroom environment, and even the classroom and the science self-efficacy. So there. So as simple as presenting the chart for the correlation between the two variables, then you have the interpretation that's a better way of presenting your result in your final paper. Well, you can still have the table if you're very used to it, but I'd like to challenge you to become more, what do you call this one, applying data visualization techniques like charts, and then of course that will develop also your being storyteller and trying to do away also with the conventional way of presenting data. So I hope things are clear in terms of Pearson's R correlation. So are you ready now to apply correlations?